Good morning, dear students. Can you see the slides?
Yes.
Yes, yes.
Okay. Do you remember last lecture up to where we did? Up to which slide? Any idea?
Up to 2, C2, H6.
This is the one.
Yes.
This
Yes.
one we finished. So now we need to do this one. Okay. Okay. So this is first law of thermodynamics. Okay. Here actually thermodynamics there are three laws: first, second, and third law. You need to study only the first law. So the mathematical form of the first law is delta U is equal to Q plus W. But you know, in some textbook instead of delta U, it's written delta E. Okay, so delta U and delta E are the same. Okay, actually, this is the total energy change, which is called internal energy change. Okay, this is not internal energy, it's internal energy change. Okay. Okay, so now Q, of course, you know, heat evolved or absorbed. W, it is work done. It can be work done by the system or work done on the system. Okay, there are two types. You know, work done, work, all of you know. Now,
Victor, can you make
no, oh, sorry, I forgot. Okay, yes, can you see now?
Yes.
Okay, so now here. Oh, okay. Yeah, now it's clear, right? So what is the old concept? I mean, in some textbooks still they are using instead of delta U, delta E. So by mistake, if I tell delta E, you need to know it's delta U. So what is that delta U? It is the internal energy change for a system. Q means it's heat evolved or absorbed. Then W, all of you know, it's work done. Now the very important thing, if heat enters the system, okay, so we have two different things. One is system and the surrounding. So usually we talk with respect to system because surrounding is too much. We can't consider the entire surrounding. So this is system and outside it's surrounding. Okay. Now, suppose if the heat is absorbed by the system, from where? If system is taking heat, absorbing heat, from where? From where?
The surrounding.
From surrounding. So that means if heat flows into the system from the surrounding, okay, so that's what heat enters the system, okay, goes into the system from surrounding, or heat is absorbed by the system. The process is endothermic and the value of Q is positive. Okay. Okay, the value of Q is positive. You know that's the endothermic process. The Q is positive. Okay. Similarly, if the heat flows from the system, that means if heat is going out of the system is losing heat. That means heat is evolved. You understand the meaning? Do you understand what I'm telling?
Yes.
Okay, so if heat goes into the system, okay, sorry, if it goes out of the system, that means system to surrounding. So system is the one losing heat. So the process is exothermic and the Q value is negative. Okay. Okay, you understood? So don't forget Q positive when the process is endothermic. That means heat enters the system. And if the heat is evolved, instead of evolved, there is another term called released. If heat is released, Q is negative
Yes,
and process is exothermic. Now next is work done on the system, work done by the system. See, work is done on the system by the surrounding, right? It's otherwise called contraction or it's called compression. I'll tell you the meaning of this. So W is positive. Now, if work is done by the system on the surrounding, that work is called expansion work. I'll tell you the meaning of this expansion. W is negative. See, just imagine, look, if I do work, I lose energy. Sir?
صح.
Okay. So that means my final energy minus initial energy is negative or positive?
Negative.
Negative, because I'm losing my energy. So that means if I do work, I will lose energy. So W will be negative. Think that way. So if you are doing work, W is negative. If work is done on the system, W is positive. So don't forget these 4 points. Okay. Now I'll tell you the meaning of the term contraction and expansion. See, look here, dears. See, this one, before that, I just want to remove, just a minute. Okay, yeah. Now, see, the meaning of, sorry? Can you ask me something? Did you ask something? No. Can you hear me clearly?
Yes.
Yes.
See, look, this part is
Yes.
can you see what I wrote? What did I write?
Expansion.
Yes.
Yes, sir.
What did I write?
Conversion.
Did you see what I wrote on this?
Yes.
See. Look, I hope you understood the meaning of this expansion now, right? From the diagram. Did you understand the meaning of expansion? Expansion, initially only this much, only this much volume. This piston, the system will do some work. Suppose if there is some work here, see, just imagine here, due to some reaction, more gas is formed. So this gas will push this piston up. This is a piston, so it will go up. Okay, so the gas inside this is doing work. So that means system is doing work. So this is expansion. See, it is going up. Okay, before only this much, now it became this much. So this is expansion. Is it clear for you? So in expansion, work is done by the system or on the system?
By the system.
Come on.
By the
Yes, system is the one doing work. Okay, now next one, look here. What's the initial volume? Initial volume is too much, right? This much volume is there. So if you press here, if you compress here, okay, what happens? The piston comes down. So initially is this much, now finally show here little. Okay, this is called compression or contraction. Here, who is the one doing work in this case?
Surrounding.
surrounding.
Yes, surrounding is doing work on the system. Okay, so work is done on the system by the surrounding. So W is, come on, W is in the first case, W is, yes,
First case.
here,
More.
W is, so here work is done by the system on the surrounding. Okay. So W is negative, right? Now here
On-
compression, work is done
On the system.
Okay, work is done on the system by the, that you need to know, okay? On the system by the surrounding. So in this case, W is positive. Okay, yeah. Now we will do the, see, this is same thing I just showed in a different diagram. Look, this is the system, this much portion is the system, and the camel outside, camel surrounding. Now look here, W is positive when work is done. Come on, done.
Done by surrounding.
On the system, on the system by the surrounding. Now, if work is done by the system, W is negative. Similarly, heat flows from the system, Q is negative. And if Q enters the system, Q is positive. Okay?
Positive.
Yes. So now we are going to do questions. See, you know the formula. What's the formula? Delta U is equal to, what's the formula? Delta U is equal to Q plus W. Okay, now. Yes, tell me how to solve it. It's very easy. Where are you?
Delta U equal Q plus W.
W. So system absorbs 470 kilojoule. This is kilojoule, K small letter, okay? This kilojoule unit is wrong. I mean, unit means it is supposed to be small k. Okay, anyway, tell me, please. Yes, tell. You tell, please.
470 is the Q.
Yeah, plus 470 or minus 470?
Positive because it absorbs.
Yes, it absorbs. Why? Okay, it absorbs, so it's positive. Now, does work. System absorb this much amount of heat and does work. So who is the one doing work now?
System.
System. So W negative or positive?
Negative.
Negative. So this one's unit is K small letter, J capital letter, kilojoule. The other one is 200 joule, but this value is negative. Okay. Now what's our form? But one of them is in kilojoule, the other one is in
We need to convert, right?
Either convert both to kilojoule or both to joule. So in the hand, when you choose multiple choice answers, check what unit is given. Okay, if it is in kilojoule, write kilojoule. Okay, otherwise write joules. So now here I'm going to convert kilojoule to joule. So it's 470 times 10 to the power 3 joules. Now our formula is delta U is equal to Q plus W. Okay. That is 470 10 to the power 3 minus 200. So and so you will get so and so joule. Is it okay?
Yes.
Okay, now. A system evolves. Evolves means release.
Negative.
Yes. 110 joule of heat and 200 joule of work is done on the system. Find the internal energy change. So tell me what's the value of delta U, Q?
Negative 110.
100.
Okay. Yes. W?
Positive 200.
200.
Work is done
On the
Positive
system.
200.
on the system.
200 joule.
Positive 200. Now formula delta U is equal to Q plus W. So that is minus 110 plus 200. So what's the value? It is 90 joule, right? Okay. Then next is
Joule.
find Q when 70 joule of work is done on the system and energy is increased by 60 joule. Yeah.
Work is 70 joule.
Okay. So W is plus or minus?
The value is
70 joule.
It is positive 60, doctor.
Sorry?
W is 60 because he said the energy increased by 60 and the work done is 70.
Okay, so now what is now delta U? Delta U is
60.
so delta U is 60. Change in internal energy 60. Okay. Yes. Now what is it, dear? So tell me the formula. Delta U is equal to Q plus W. So come on.
U equal delta U minus W.
Yes. Q is equal to delta U minus W. 60 minus 70 is equal to minus 10 joule. Correct?
Yes.
Correct? Hmm?
Yes.
Okay. Okay. Yeah. Tell me now.
Work is minus 50 kilojoule.
Yes. W is equal to minus 50 kilojoule. Okay. Yes. Then.
Minus
Minus 20.
Yes.
Physical.
Delta U is minus 20 kilojoules. Correct. Units both cases same, right? Your previous case I forgot. Let me see. Both units same. Okay. Okay. Correct. Okay. Yes. Tell me now. Yes. Delta U is equal to Q plus W. So Q is equal to delta U. Okay. Minus W. So it is. Come on.
Negative
Minus
20
20.
plus 50.
Yeah. So it will be plus
Positive
30.
30 kilojoule.
Minus.
Correct now? It's very easy, no? Please in the hand don't make mistake, okay? Careless mistakes you should not make. Oh. Okay. No, that's done. Delta H versus delta E. It's not delta E, actually it is delta. Come on, tell me. Delta
U.
U. Okay. Okay. Yes. Delta H versus delta U. This I told you already. Do you remember? QP. Heat flows. Okay. Heat change. Heat evolved or absorbed at constant pressure. Then delta U is the heat evolved or absorbed at constant volume. Do you remember how to find the value of delta H? I told you this. How do you find the value of delta H? Come on. Can you give me a device which can be used to find the value of delta H? That means you didn't revise anything. That's why. Okay, you can use coffee cup calorimeter. Using coffee cup calorimeter, you can find it. And anyone, can you tell me how do you measure the QV? That is delta QV. How do you measure QV? Heat evolved or absorbed at constant volume? Using
Calorimeter.
yes, using Bohm calorimeter. Bohm calorimeter. Here you can use coffee cup calorimeter. Not really coffee cup, okay? Because this is the only thing familiar for you. Okay, so now here we have a relationship. H is equal to U plus PV, where H is the enthalpy, U, what is U? Come on. What is U? What is U?
The change in energy.
Internal energy, okay? Here, U is internal energy, P is pressure, V is volume. Okay, so now we are going to find a change. This is mathematics we apply. So now delta H, change in enthalpy. Okay, so I will write here one more enthalpy change. Just a minute. Delta U is called enthalpy change. And delta U is called, what is it? Internal energy change. Okay. Now H is equal to U plus PV. Now we find the change in change in delta U. Change in delta H. Delta H is equal to change in H. That's delta H. Delta H is equal to delta U plus delta PV. You understand? You put delta everywhere.
Yes.
Right? So you studied this equation. Do you remember PV is equal to nRT? This is called which equation? PV is equal to nRT. What is the name of that equation? PV is equal to nRT.
Air pressure.
What did you tell? What is it called? Ideal gas equation. From ideal gas. What?
Delta is for pressure and volume.
Yeah, change in pressure and volume. Okay, so now here, so PV is equal to nRT's ideal gas equation. So now what is delta P here? From this, delta P is equal to, tell me. Yes, delta PV is equal to delta nRT. Okay, so you can substitute the value of delta PV. So now what do you get? Delta H is equal to delta U plus delta nRT. Did you understand something? You want me to explain again?
Yes.
Yes, please.
Okay, see, I will write it better, okay? Then you will understand. Okay. H is equal to U plus PV. Okay, now I am going to find the change delta H, change in enthalpy is equal to delta U plus change in both of them, pressure and volume. Okay, okay.
Okay.
Yes.
Now all of you know PV is equal to nRT. This is ideal gas equation. So this is applicable for gases. So here P is the pressure of the gas, V is the volume of the gas, N is the number of moles of the gas, R is constant, T is temperature. Okay. So now here, so you can find from this delta PV. See, delta PV is equal to, come on, tell me, delta
RT.
Delta, please tell yes. Delta nRT. So I found delta here. Delta. Okay, so this is equation number 1. This is equation number 2. So, okay? Okay?
Oh.
Now, substitute the value of delta PV in this formula. Substitute 2 in 1. Substitute this one here. So what do you get? Tell me.
Delta H minus delta U.
Yes, so delta H is equal to delta U plus, instead of delta PV, you write this. So what do you get? Delta nRT. Now understood? Did you understand?
Yes.
Okay, so now this is the formula. Delta H is equal to delta U plus delta Ng. So what's the meaning of delta Ng? Delta N, I told you this is for gases. Number of moles of gas products minus number of moles of gas reactants, so that is delta N. It's there on the next slide. So just a minute. You understood all this? No, that's why I'm rubbing all this. Otherwise, it's not a okay. So here I will write it. This is equation number 1. This is equation number 2. Substitute 2 in 1. Now I'll go to the next one. The same thing. Oh, again there is a mistake. What is the mistake here? Can you tell me what the mistake is here? Instead of delta.
Delta N.
Not delta n, my dear. Delta, this is delta. Both are same. Some textbook it's delta U, some textbook it's delta E. Because the textbook which you follow, it's now delta U. Previous textbook it was delta E. That's why the notes it's like that. Okay. So now here delta H is enthalpy change, delta U is internal energy change. Now the most important thing over here is the value of R. The value of, what's the value of R? 8.314. You need to know that 8.314 in terms of joule you need the values. Okay, don't use 0.0821. 0.0821 is liter atmosphere value, so here joule value is different. Okay, don't forget, this is very important. Now since R is in joules, so if this one is in joules, of course this must be in joules, this also must be in joules. Did you get it?
Yes.
Yes.
Okay,
Yes.
so that means enthalpy change should be in joule. Internal energy change also should be in joules, and temperature must be in
Kelvin.
Kelvin.
Now delta Ng. So what is, or you can just tell delta N. That means what is NGP? NGP delta N is equal to number of moles of gaseous products. That means products in the gaseous state minus number of moles of gaseous reactants. Understand? Understand?
Yes.
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 Okay. Yes. So now okay. Yeah, okay, so we will solve the questions. Okay, don't forget the formula. Delta H is equal to delta U plus delta nRT. Okay, here and there's a question. Delta H for the following reaction is this much kilojoule. Find delta U at 25 degrees Celsius. Tell me how to solve it. Tell me please.
Convert the temperature to Kelvin.
Okay, you must convert degrees Celsius to Kelvin. Okay, then
Write the formula.
yes. Okay, so first of all, I'm going to find the value of delta N. Okay, delta N is equal to number of moles of gas products minus number of moles of gaseous reactants. Okay, now you know which are products. These are products and these are called, come on,
Yes.
reactants. Okay, so now tell me how many are there? Gaseous products, how many are there? Here, how many? This is a gas, right? This is a gas, it's 2. This is a liquid. Can you take liquid? Will you take
No.
liquid? Will you take liquid?
No.
No. So the product side, it is 2 minus reactant side, phi gas. So this is a gas. So you can take 1 here. Here, this is a gas. How much it is? 5 over 2. So 5 over 2. So 2 minus 5 over 2 is equal to minus 0.5. Correct?
Yes.
Doctor,
Yes, dear.
Must add 1 or
Sorry?
5/2 plus 1 because
Oh,
there's
sorry, I am sleeping, right? Okay, so what will be the answer? Minus 1.5, right? Correct? Correct now?
Yes. Yes.
It's minus 1.5. Yes. Now tell me, please. Next step. What's the value of delta H? Delta H is equal to minus 1250. Come on, come on, come on, come on.
Kilojoules.
Yes, 10 to the
multiply
power 3. Come on, you must convert kilojoules to joules. Okay. Now T. How do you convert T to Kelvin? 25 degrees Celsius plus, come on,
73.
27.
27.
273.15. So it is 298.15 Kelvin. So in the exam you write 273.15. Okay, that's more correct. Now our formula: delta H is equal to delta U plus delta nRT. Okay, so delta H is minus 1250 10 to the power 3. Delta U we don't know. Delta N you know minus 1.5. The value of R is 8.314 joule. Kelvin inverse, mole inverse is there, okay? Times T is 298.15 Kelvin. Okay? Yeah. This much is, this is joule, I forgot to write. This much this much mole, right? This is also mole, 1.5 mole. So what will happen? Kelvin inverse, Kelvin get cancelled.
So R
Yes.
is in Joule.
Yeah, dear.
R is
Okay.
in Joule.
Yeah, 8.314, right? Mole inverse, mole get cancelled. Kelvin inverse, Kelvin get cancelled. You get delta U, so and so joule. See, I told you, no, dear. Previous slide. Look, what's the value R? What's the value R? Can you see? Did you see? Okay. It is 8.314. Because the other things are in joules. The other value of R, I will write it. See, I'll tell you the unit. So you have another R value, it is 0.0821. The unit is liter, atmosphere, Kelvin inverse, mole inverse. So here we are not using delta H and delta U are in joules. So you cannot use liter, atmosphere there. Okay? Understood?
Okay.
Okay,
Yes.
that's why we are using
Yes.
joule value. So in the exam, don't make it wrong, okay? PV is equal to nRT, we use always 0.0821, but then here we use joule value. Yes, this one you have to help me, please. Tell me how to solve it. Yes. Please tell.
We should build the equations.
Yes, first step you have to write the equation. Second step.
And delta H.
Okay, you have to find delta.
H.
N.
Okay, and then you have to find delta U. Okay, it's a very good question. Right? No? Okay, this is supposed to be liquid, okay? Liquid. Okay, and now the other things are gases. Even this also is a gas, okay? Methane also is a gas. I didn't write that also. Bracket G. Okay, fine. Yes, you can help me. Yeah. Question. Tell me, dears. Come on. Combustion, you know. Combustion means burning. Okay, yes. Come on.
O2.
Yeah.
CH
CH4 plus
plus O2.
Oxygen.
O2 will give you, tell me. Yeah.
CO2.
CO2 plus 2H2O. My dear, combustion, there is something as per the definition of combustion, you have to burn 1 mole. Here already 1 mole. Now balance the oxygen atoms. How many oxygen atoms are? Hydrogen is balanced oxygen. Right hand side 4 are there. Left hand side we have only 2, so make it 4. Okay, so now next step, I don't know. This is a gas. Here gas. This is H2O is liquid. Yes, tell me please. What is this delta H0F? What does it mean delta H0F?
Formation.
Formation, yes. So now tell me. Tell me the formula. Delta H is equal to sigma
Sigma of delta H formation.
enthalpy of formation of products minus sigma enthalpy of formation of reactants. Okay, so now the products, what are the products? That is enthalpy of formation of CO2
0
plus 2 times enthalpy of formation of H2O, correct? Correct?
Yes.
Minus
yes
enthalpy of formation of, tell please,
Is H4.
CH4 plus enthalpy of formation of O2. Okay, please tell me the substitution. CO2, what's the value? Minus 393.5 kilojoule per mole plus 2 times for H2O minus 286. I made mistake.
Multiply delta HFO2.
Okay, fine. Okay. Yes, okay. Now, so tell me, dears, tell me minus minus 75 plus, come on,
0
2 multiply by 0. Why is it 0?
element
Yes, oxygen is an element. Okay, can you please tell me the answer for this one? I don't have the answer.
Minus 890.5.
Minus 890.5. What's the unit? Kilojoules. Okay. Okay.
Okay.
So this
Okay.
is delta H. Now you tell me the next step, please.
The moles of gas.
So first of all, now you have to find delta U, right? Okay. Yes. Help me, please. First of all, I have to find delta N. Number of moles of gas products
minus
number of moles of gas reactants. Yes. Tell me how many are there? Products, how many are there?
1
1.
1. Why only 1? Why don't you take H2O?
Because
liquid.
It's a liquid. Okay. Minus. If I make mistake, you should tell me. CH4. How many mole?
1
1.
1.
Oxygen, how many are there?
2.
2. So the answer is minus 2 mole, right?
right
Okay.
yes
Correct. Okay. So now you know the value of delta H. Delta H is minus 890.5. The most important part. Here only you lose marks. Okay, dears. 10 to the power 3. Come on. Why did I make 10 to the power 3?
Joules to joules.
Joule.
make it joule
Kilojoule to joule. Okay. Joule. Now the formula is delta H is equal to delta U plus delta nRT. That is minus 890.5 10 to the power 3 is equal to delta U plus minus 2 mole times, what is it? Var value 8. 314. I don't have place to write the unit. You are supposed to write the unit. My dears, if temperature is not given, always we take it as 25 degrees Celsius, okay? Because enthalpy of formation is as per 25 degrees Celsius. So at 25 degrees Celsius, if not given, okay? So 25 degrees Celsius means, come on.
298 Kelvin.
Yeah, 28.15 Kelvin. Okay, so here T is 225 degrees Celsius plus 273.15, so that is 298.15 Kelvin. Okay, there is no place. Okay, you will be able to get delta U so and so joule. Okay, understood?
Yes.
Okay. Anyone has any doubt? Anybody has any questions?
Clear.
No.
Okay, clear. Now we'll move on to the next one. Okay, so next question is, find the difference between delta H and delta U for the following reaction at 27 degrees Celsius. Okay, you tell me how to solve it. Yes, tell me, what's the meaning of difference between delta H and delta U? My dear, hello? Difference between, what do you mean by difference between? Delta H is equal to delta U plus delta nRT. The difference means delta H minus delta U. This is the meaning of difference. One minus the other one. That's the meaning. Difference is equal to delta nRT. Tell me the value. What's the value of delta in here? Number of moles of gas products minus number of moles of gas reactants. Yeah. Where are you?
3.
2 minus 2. Oh. Where is it? Two minus 2 plus 1 is equal to minus 1, right? Okay, so now that's equal to minus 1 mole times 8.314 joule Kelvin inverse mole inverse times T is 27 plus 273.15. So that is equal to 300.15 Kelvin times 300 Kelvin. So you will get some mole and mole get cancelled, Kelvin inverse Kelvin get cancelled, and you get the answer so and so joules. Okay, mole inverse mole.
Victor, you said
Kelvin
before.
inverse Kelvin. So yes, yeah.
You said before if it's the equation is for compression, it must be 1 mole.
Just a minute, 1 second. 0.15, I forgot to write. 1 second, I'll come back to you. Okay, so you will get your answer. Yes, dear, what did you tell me?
You
What
said
did you tell?
before, in the previous question, you said before CH4 must be 1 mole if you write the equation.
No, dear, that is different case. Okay, sorry. What is given in the question? Combustion. Right? You know the meaning of this. I will write it on the slide. Good, you asked me. Okay. See, enthalpy of combustion. We did enthalpy of formation, right? Similarly, enthalpy of combustion means it is the enthalpy change when 1 mole of a compound is burned in excess of air or excess of oxygen when the reactants and products are in their standard states. So this is the basic meaning. So that means if the question is for combustion means ihtirak. We did enthalpy of formation. Do you remember? It is enthalpy change for the formation of 1 mole. So similarly, it is enthalpy change when 1 mole of a compound is combusted or burned in excess air. Now it's okay? Understood what I meant? Did you understand? So that is why there it's 1 mole. Otherwise also when you balance, it's coming as 1 mole. Sometimes it will not come as 1 mole, so at that time you should not change it. It has to be 1 mole. Okay, so we finished this lesson. This lesson is easy or difficult? You tell me.
Easy.
Easy.
Okay, in the exam you will get full mark or not? Tell me that.
Depends on the
full
result.
mark inshallah.
If you make it easy, we
Another
make
question also.
help us, doctor, huh?
My dear, it's very easy, but the problem with the exam is exam time, I don't know, somehow you make it wrong. Even though, because so many calculations, you know the problem. Maybe you don't get used to the calculator. So if you don't practice the calculations, you cannot do fast. It takes too much time. Okay, and especially the system. Now, if there is mistake, you will lose marks. If some questions next, unlike the previous quiz, it was all multiple choice. Now this test one is not like that. Yes, you have to write the answers. When you write the answers, if the answer is different, you lose marks, no marks for the steps. So you have to do the calculations properly. For that, you have to take your calculator and check whether you can do it properly or not. Every question you just do the calc, or you just bring the calculator in the class also. When we do the calculation, same time itself, you do the calculation and tell me the answer. Okay? Difficult questions, all I gave you the answers. These all are simple questions. Okay, so everyone understood. So yesterday somebody was asking me they need the notes. I mean, like, so I will upload it now after this. Okay, and I don't want to start a new lesson. How many minutes? Oh, it's time is up. Okay, okay, dears. So now, yeah.
Doctor.
Yes, tell me. Yes.
Time for test is not okay. It is at pray time. We want to pray.
What time is the exam?
It is from 6 to 8. Can you put it 6 and a half?
What time you are praying? 6:30?
No, 6. We should pray at 6.
Okay, so I will check with other doctors also, and then will make it. So if it is 6:15 or 6:30, will it be all right for you?
Yes.
Okay, I will check with them. Okay.
Okay, thank you.
Yeah. Okay. So everyone, it's okay, right? Yeah. It's prayer time. It's not good. Yes.
Doctor?
Yes, dear. Tell.
Have we finished the material for test 1?
Test 1, actually, I didn't discuss with Dr. Salim and Dr. Abdullah. Let me see, maybe we finished. I finished this lesson. I don't know whether they finished or not. Okay, please, those bomb calorimeter questions you practice. I will check with them, both of them, and then I will let you know. Okay?
So until this lesson, we have finished the material for the test.
Yeah, this lesson I finished. Okay, I don't know if we will add next lesson or not. Okay.
Thank you, doctor.
Yeah, okay, so I'm going to upload it now itself. So you can find it. You have the syllabus now, and that in Teams, it's there in the syllabus is there. Did you find it? You have to find it, please, okay? And you know where when it's in the what do you call syllabus, the date is 27th, but your exam is on which day?
25.
25. It is on 25, okay? Is it okay? Some
Yes,
people have some clashing, or that only or 2 or 3 students have clashing. But we don't get another day, so that's the reason. Okay? Yeah, okay. Bye, dears.